Okay, this is the data collection video for Remote Lab 2. Okay, that's the Pendulum Lab. What I'm going to be doing is I'm going to be doing, if you refer to your handout, I'm going to be doing part 4A, which is the experimental procedure data collection, okay, for the pendulum. So refer back to your handout if you're not sure what that is. Okay, so here's the idea. The idea is we're going to measure the period of a pendulum. In fact, we're going to measure 10 periods, the time it takes to go back and forth 10 times and divide by 10 to measure the period of a pendulum with a given length. Okay, what I have here is I have a stand and I have a length of twine. I've marked my twine out at 10 centimeter increments. As you can see with these black, perhaps you can't see it, but I have black dots where the 10 centimeter increments are on this twine. I have a 200-gram hooked weight, okay? And the hooked weight, I'm going to measure the lengths of the pendulum from the center of this weight, right? So I'm pretending that all the mass is located essentially at the center of mass of this weight, which is at the top of this yellow band, okay? And that's that will be the zero length for the string, okay? So what I'm going to do is I'm going to hang this weight from this string, okay? And I will adjust the length, and then I'm going to extend this by less than 15 degrees to keep the angle small, let it go, and let it swing back and forth for 10 full swings. I will tell you when I'm letting go. You should start your stopwatch at that point. I will count 10 swings, and you will stop your stopwatch. That will give you your time for 10 swings at that length. And then those are the data you will use in your analysis when you do the analysis for this lab. And we'll do that for 10 different lengths of string. Okay, so hopefully that is clear to you. So let me start by the shortest length. So I'm going to have a length of string of 10 centimeters. Okay, so I'm going to clamp my string at 10 centimeters. Okay, where I've marked it to be 10 centimeters long. Okay, which is way, 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 way up here. That's 10 centimeters. Okay. So, and I'm going to hang my spring like so. Okay, and I've measured that so that this length right there, okay, from the center of the mass to where the string is attached is exactly 10 centimeters. I'm going to now let this go from about 15 degrees and count 10 periods. And I want you to make the measurement of 10 periods with a stopwatch or your phone or whatever. Okay, so ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. Okay, that's 10 periods. So if you didn't get to measure that, rewind the video and then measure it. Measure that time because that's your first data point. Now I'm going to go to 20 centimeters. So I'm going to clamp this at a 20 centimeter length, as I've marked right there. Okay, and hook my spring back up. Okay, are you ready? Here we go. 15 degrees approximately or less. I'm going to measure. I'm going to let it go for 10 periods. Ready? Go. 1, 2, 3, 4, 5, 6, 7, 8, 9, stop. That was your second data point. At 20 centimeters length. Okay, my first was 10, that second one was 20 centimeters. Now I'm going to go to a 30 centimeter length string. So my 30 centimeter length string is there. Okay, this is 30 centimeters from where it's clamped to the center of the mass. Okay, we're going to do the same thing again. So about 15 degrees, and we're going to make allow it to do 10 periods and measure that time. So ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, stop. That was at 30 centimeters. Okay, now I'm going to go to 40 centimeters. There's 40 centimeters. Okay, so there is a 40 centimeter length of string from here to here, and we're again going to do a measurement of 10 periods. Okay, small angle, ready, set, go. I didn't do that right. That again. Ready, ready. Okay, here we go. Ready, set, go. 3. I screwed it up again. Let me try that again. Ready, set, and go. 1, 2, 3, 4, 5, 6, 7, 8, 9, stop. That was 40 centimeters. 50 centimeters. Next is 50 centimeters. There's my mark, there's my mark. 50 centimeters. Okay, for 50 centimeters. Here I have a length of string of 50 centimeters from here to here. Small angle displacement, and I'll release in a second. Get your stopwatches ready. Okay, ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, and stop. Okay, that was 10 periods at 50 centimeters. Now I'm going to go to 60 centimeters. There is my 60 centimeter length of string. Look, my mass. So from here to here, it's mass 10, 20, 30, 40, 50, 60 centimeters. 60 centimeter string, small angle displacement. Get your stopwatch ready. Set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, stop. Okay? 70 centimeters. Okay, for 70 centimeters, that's 10, 20, 30, 40, 50, 60, 70 centimeters. Small displacement. Okay, and ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, stop. Okay, that was 70 centimeters. 80 centimeters now. Unclamp. Clamp back up again. Like this. So that's 10, 20, 30, 40, 50, 60, 70, 80 centimeter string. Here we go again. Small displacement. Ready. Get your stopwatches ready. Set. Go. 1, 2, 3, 4, 5, 6, 7, 8, 9, stop. Okay? Let's go on to the next one, which I have marked. And that's the last one I have marked. Okay? So 10, 20, 30, 40, 50, 60, 70, 80, 90 centimeter pendulum. 90 centimeter pendulum. I'm going to displace it by about less than 15 degrees. And when you're ready, set your stopwatch. Ready, set, and go. 1, 2, 3, 4, 5, 6, 7, 8, 9, stop. Okay? So those are your data points. Your independent variable, your x variable, is the length of the pendulum, from 10 centimeters to 90 centimeters. Your dependent variable, your y-axis, is going to be the period, which is 1/10 of the time you measured, 1/10 of the time you measured for the 10 swings. That's your period. Okay? So I'm not going to go through this again and do it again because it just takes too much time and I don't want to spend more time on this. So I want you to estimate what you think your uncertainty is in terms of your measurement of time. Okay? You know how fast you can respond, how well you think you can make the measurement of that time period. So do your best estimate of the uncertainty or the random error in your measurement of time based on how quickly you could react to my calling out stop. Okay? So those are the data for the Pendulum Lab, and you will analyze those according to the instructions in Lab 2. Okay? Pendulum. All right, that's it.